For our project, we decided to do Highway 82, the Centerville Bypass. This project is located about 35 miles southeast of Tuscaloosa. It is it is a project that is owned by the Alabama Department of Transportation and is operated by Raycon Incorporated. The project is approximately 2 miles long. It is going to bypass the downtown Centerville and keep traffic moving straight through 82. And the equipment we observed was a motor grader, a scraper, and a sheet foot roller. The scrapers were used to move the dirt that was already on site and out of the high hill areas into the low valleys. The sheet foot roller was used for compaction, and the motor grader was used for the grading between lifts and final grading. This is a picture of the finished subgrade after all the lifts have been put in place. This project is set up to do in sections, which helps with erosion control, and that each section has to be completed before the next can be started. And this is one of the sections that all the grading has been done and the base layer has been put on. This is a box culvert that was located at the south end of the job site. They had some cracking issues, and we just went down there to observe what they were doing there.
Here's the Easy Strobe model that we came up with. We used 5 scrapers, 1 motor grader, and 1 sheep's foot roller, and we chose this cycle because of the repetitive nature of the activities performed and the ease with which we could make this model in Easy Strobe. The actual project itself will involve 2 more lifts, both with the motor grader and the sheep's foot roller. Here is the sensitivity analysis that we performed. We started off with what was given, the 5 scrapers, 1 motor grader, and 1 sheep's foot roller. And from there, we first adjusted the motor grader, added 1, because the material 2 had no wait time initially. And from there we just kept going and analyzing things with that. And further from there, we chose to compare the costs for tests 1, 4, 6, and 7. Here are the activity durations that we observed while on site. And here are the model durations that it gave us that we used to perform the validation.
This is the cost estimate table we came up with. And for these numbers, we contacted the project manager, Terrence Williamson, to get the operator cost in dollars per hour, and we got that to be $16 per hour. And then for the equipment cost, we used the RS Means manual. We found the total operation cost of each piece of equipment to be $1696.50 per day for the scraper, $885.50 per day for the motor grader, $858.50 per day for the sheep's foot roller. All these values were found with the assumption of a 10-hour workday. The most efficient cost is clearly the option number 6. And then this is just a table showing the production values versus the cost of each equipment. And the most productive option was number 6 also.
Our group members consisted of Alex, Clint, Bryce, and Holly.